Dear students, we have already seen in numerical integration ki how the Newton-Cotes formula you can derive with the help of Newton-Cotes formula, Simpson's 1/3, Simpson's 3/8 and trapezoidal rule. Now today we are going to discuss ki what is the basic concept behind all these three methods, and in any one particular problem we will try to solve with the help of trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule, and which method is better. So this is the today task, and I think it will be clear to all the viewers. If any doubt in numerical integration, especially related with trapezoidal rule, Simpson's 1/3 and Simpson's 3/8. So let us look the problem. Uh, this problem is there. Ki evaluate this 0 to 1 dx by 1 plus x square by using first trapezoidal rule by taking h is equal to 1 by 4, Simpson's 1/3 rule by taking h is equal to 1 by 4 or the similar same value, and the Simpson's 3/8 rule by taking h is equal to 1 by 6. Okay. Uh, Now how to solve? The first, I think the value of the function, it is already given, that is 1 by 1 plus x square, and for first two cases, since the space are equal, h is equal 1 by 4, then we can develop the table, this table, and we can tabulate the value of x and fx. For different value of x, you will get the different value of fx. So with the help of your calculator, you can find out these values. If by putting x is equal to 0 here, you will get fx, that is 0, 1 by 1 plus 0, that is 1. Similarly, x is 1 by 4 here, then you will get 0.9412. If for x is equal to 1 by 2, you will get 0.8000. For x is equal to 3 by 4, you will get 0.6400. And for x is equal to 1, of course, here 1 divided by 1 plus 1, 2. 1 by 2 is 0.5000. Okay. So you got the different values of x and fx. Okay. Now further, you know ki by using trapezoidal rule with h is equal to 1 by 4, you may express your trapezoidal rule formula for this particular problem, that is h by 2 f naught plus 2 times f1 plus f2 plus f3 plus f4. Okay. So this formula you have to remember, and you can apply here in this particular problem. Then by putting all the values as discussed in the previous tabulated table, this is 1 by 8 because h was 1 by 4, so 1 by 8, and then f naught is 1 plus 2 times f1, f2, f3 you can look in the table, and the values are here. f1 is this, f2 is this, and f3 is this. Okay, plus f4 value is this. So in if you will solve and simplify, then you will get 0.7828. This is the value of this integral. Okay, by using which one? By using trapezoidal rule. You have applied the trapezoidal rule and you got this value. Now similarly, by using Simpson's 1/3 rule with h is equal to 1 by 4, first of all you have to write what is the formula in application. And the formula in application is h by 3 f naught plus 4 times f1 plus f3 plus 2 times f2 plus f4. Okay, so you got this formula. Now putting from the table again the values, and f naught is 1, f1 plus f3 you may write this. This is the f1, this is f3, then 2 times this is f2, and then f4. Okay, and in calculation you will get 0. Just to check, you will get 0.7 0.7854 by using the Simpson's 1/3 rule. Okay, and here just to notice, in the case of trapezoidal you have only 0.7828, but here 0.7854. In compared to this is better, with better accuracy. And similarly, you may find the Simpson's 3/8, and the value for fx is equal to 1 by x square, since the space was different. Space is 1 by 6 here. Okay, 1 by 6 here. So for this space for the given interval is equal to 1 by 6, you have to develop this table. Again, for different values of x is 0, then 1, x is 1 by 6, then 0.9730, x is 1 by 3, then 0.9000, then if x is 1 by 2, then 0.8000, and if this is 2 by 3, then 0.6923, if this is 5 by 6, then 0.5902. Okay, so now this is 1 by 0.5000 for the different values. You may say for the value of 1 by 6, if h is 1 by 6, then you can develop this. Now, by using the Simpson's 3 by 8 rule with h is equal to 1 by 6, you may write 0 to 1 dx by 1 plus x square 3h by 8, and the formula is for this purpose only. This formula is 3h by 8 f naught plus f6 plus 3 times f1 plus f2 plus f4 plus f5 except f3. Okay, so here is f3, 2 times f3. Okay, so you have to remember the formula. Now, after putting all the values and make the simplification, you will get, just to look, 0.78541. Okay, and since this integral is the very famous integral, so I'm leaving for the viewers, you can find out the exact value by integrating this, because this is very you are familiar with this integral, and with the help of the scientific calculator you can find out the exact value, and then you can compare which value is more closer among all these three calculated values. Okay, it is what is the key concept behind all these three methods? We can use numerical integration, as we know, to estimate the values of definite integral when a closed form of the integral is difficult to find, or when an approximate value only of the definite integral is needed. Okay, so this is the requirement, why this is the need, why you are studying here the numerical integration. Okay, in many cases it happen in the real life problem. It is very difficult to find the integral. So in that case, you can use the approximation, and for that purpose you can use the numerical integration. Okay, because integration is always a summation. So this is all these three methods. This indicate the technique is different. The summation technique is also different. Okay, so in this way you can calculate the value. The second basic concept is the most commonly used techniques for numerical integration are the midpoint rule. Okay, this is already we discussed, and it is just you go through and review again. The midpoint rule, trapezoidal rule, and Simpson's rule. Okay, so for your sake of information, I have taken here. If you are interested, then you read in detail. The midpoint rule approximate, अब ये क्या करता है? This approximate the definite integral using rectangular region. So this is the basic concept. ये midpoint क्या करता है? Rectangular region. Whereas जबकि trapezoidal को क्यों हम पढ़ते हैं? Because trapezoidal rule approximate the definite integral using trapezoidal approximation. Trapezoidal approximation. Simpson's rule क्या करता है? The Simpson's rule approximate the definite integral by first approaching the original function using piecewise quadratic function. So this is also a very important. This is a piecewise quadratic function. Whenever you build up any real life problem, then we always believe in piecewise continuity. And that is the basic concept of integration and development. Okay, so step by step, piecewise. Now, it is clear from the example that the Simpson's rule errors decreases fastest. So, although you have not calculated error, but you can calculate the error and you will feel this. And how to calculate this exact value and then approximate value, then you can find out what is written here. So, this method is the best one. It is also clear that Simpson's 3 by 8 rule is similar to Simpson's 1 by 3 rule. It is clear in the numerical also. The only difference being that for the 3 by 8 rule, the interpolant is a cubic polynomial. This is the basic difference. And now the 3 by 8 rule uses one more function value. क्यों? क्योंकि ये क्यूबिक पॉलिनोमियल से डिराइव होता है एंड इट इज अबाउट ट्वाइस एज एक्यूरेट एज द 1/3 रूट. More better is always Simpson's 3 by 8. By and large, if you look a lot of problems, then you will conclude that that method is more better. Although in compared to trapezoidal, Simpson's rules are better, but in compared to Simpson's 1/3 and 3 by 8, then Simpson's 3 by 8 is more better, twice as accurate as the 1/3. Okay. So now this is regarding all these three methods. Thank you very much. Thank you.